Okay, got it this. So these are the properties of the given section also. So we have calculated ZP value again, and these are the properties H. Also we can say D is D or H. Okay, so this is the step number 2. One of student asked me about how to convert this into centimeter raised to 4 into mm raised to 4, because in the your steel table, the Ix is equal to, value is given 7332.9 centimeter raised to 4. This value is given. So I have multiplied by 10 raised to 4, then my value is coming into mm raised to 4. So why it into 10 raised to 4? This is the centimeter raised to 4. Now 1 centimeter is equal to how much mm? 10 mm. So this is, so here centimeter raised to 4, so here 10 is there. So if we, this is for 1. आर यू गेटिंग? जर ह्यानं 10 मल्टिप्लाय केलं तर ते एकदा आपल्याला येणार आहे, पण हे सेंटीमीटर रेस टू 4 आहे. फक्त हे जर सेंटीमीटर असतं 7332.9 जर फक्त सेंटीमीटर असतं, हा जर रेस टू 4 नसता तर मल्टिप्लाय बाय 10 केलं असतं. रेस टू 4 आहे, सो वी हॅव टू मल्टिप्लाय बाय रेस टू 4, सो इट विल come into mm raised to 4. Are you getting, Amol? 1 centimeter is equal to 10 mm. जर 7332.9 एवढी व्हॅल्यू असती आणि जर सेंटीमीटर असती तर त्याचं कन्व्हर्जन 10 न मल्टिप्लाय केलं असतं. आता इथं सीएम रेस टू 4 आहे म्हणून 10 रेस टू 4 करायचं आपल्याला, म्हणजे आपल्याला ते mm रेस टू 4 मध्ये मिळेल. आर यू गेटिंग? Okay, so now next step number 3. What is step number 3? Classify the section. Step number 3, classify the section. So how to classify the section? So for flange, first we have to classify for flange. So for flange, BF by 2 divided by TF. BF by 2 divided by TF. BF is how much? 150 divided by 2. TF is 9.4. So how much this value? How much? This is 125 divided by 9.4. I think 7.98. 7.98. It is less than 9.4. Correct? Less than 9.4. It means section is plastic. It means section is plastic. Now for wave we have to classify. So D divided by TW. So D is 300 divided by TW. How much TW? TW is 6.7. How much this? 44.77. It is less than 84. Hence again plastic. Hence plastic section. So for web and flange, both section is plastic. Okay. So step number 4 is over, or 3, sorry, 3. Now step number 4. Step number 4 is design shear force, sorry, design shear strength for resistance. Design shear strength for resistance. So we have to calculate VDR. So VDR is equal to what is formula for VDR? Fy into AW divided by under root of 3 gamma m naught. So here AW is equal to H into TW. So H is 300 and TW is 6.7. So 300 into 6.7 is 210, I think. This is the areas. AW is the area of wave. Okay. Now calculate VDR. Fy is 250. Here VDR is equal to Fy is 250. AW is 210 divided by under root of 3 into gamma m naught is 1.1. So how much VDR? How much VDR is in kilonewton? Because this is the shear strength. Tell me fast. 263.74. 263.74. Okay. So here we have to check. So check for shear is the VDR should be greater than VD. So VDR is 263.74 and VD is 120. Correct? 120 kilonewton. This is the first check. And second check is VD should be less than 0.6 into VDR. So this is 120 and this is 0.6 into 263.74. So this is safe, this is also safe. So hence safe. Okay. So how much this value? 0.6 into 6 into 263. किती येते ही value? 0.6 into 263 is 158. It means correct. 158 point, and this is 120. Okay. It means 120 is less than 158 and this 263 is greater than 120. So hence safe. The section provided is safe. Now step 5. Design bending moment. Design bending moment for resistance. design bending moment for resistance. So the beam is laterally supported here. Beam is laterally supported. If the beam is laterally supported, then MDR is equal to beta B into ZP into Fy divided by gamma m naught. So value of beta B is 1, ZP value is 557.3 into 10 raised to 6 into 250 Fy divided by 1.1. So how much MDR? The formula is correct, whatever I have written. Here ZP value is given. How much ZP value? 557.3, correct. Tell me MDR. Is this 10 raised to, I think this is 10 raised to 3, no? This is 10 raised to 3. Okay. So how much? Please tell me answer fast. 126.66 kilonewton meter. Okay. So here check for bending moment is MDR should be greater than MD. So MDR is 126.66 and MD is 120. So hence safe. Correct? Hence safe. Okay. Next, step 6. Step number 6 is checks for design of beam. So first check is check for web buckling. Check for web buckling. So check for web buckling, FWD is equal to B1 plus 2N1 into TW into FCD. So we have to calculate here. So B1 is 150 mm. N1 is equal to D by 2. So D is 300 divided by 2 is 150 mm is N1. So TW is I think 6.7 mm. Now we have to calculate FCD. So similar to last, calculate FCD. So for calculation of FCD, we have to calculate, to find FCD, we have to calculate slenderness ratio, lambda. So 2.425 into D divided by TW. So 2.425, 425 China. Please check. So into D is 300 divided by TW is 6.7. So how much slenderness ratio? So how much slenderness ratio? 108.58. Okay, slenderness ratio is here 108.58. Okay, so now for buckling class C, and Fy is equal to 250 Newton per mm square. So from table number 9C, page number 42, IS 800. So calculate lambda and FCD values. So lambda 1 is 100 and lambda 2 is 110 and lambda value is 108.58. Tell me FCD1, FCD and FCD2. How much FCD1? Table number 9C, 108 is the lambda. So for 100 and 110, how much is the, this is the 107 and this is the 94.6. Okay, 94.6. So FCD1 is 107 and 94.6. Okay, so now by interpolation calculate FCD value. So FCD is the FCD1 minus lambda 1 divided by lambda 2 minus lambda 1 into FCD1 minus FCD2. So this formula should be keep in mind. You have to write very fast this. So FCD1 is 107 minus lambda is 108.58 minus 100 divided by 110 minus 100 into FCD1 is again 107 minus 94.6. So how much FCD? .08 Newton per mm square, because this is the design compressive stress is there. 96.36 or 96.08, which I should take 96.08 or 96.36, any other? Okay, 96.36. 96.36 is the final answer. Okay, so now put these values into the formula of FWB. So B1 is 150 plus N1 is again 150 into TW is 6.7 and FCD is 96.6. So how much strength for buckling in kilonewton? Here 2n is there or only n is there? Please, 2n is there or n? 2n. Okay, so here we have to multiply by 2. 2 into, so 2 into 150 is here. 2 into 150. Tell me answer. Very fast. 290.53. 290.53 kilonewton is the buckling strength for the beam. Okay, so now second check we have to take, that is check for wave crippling. So FWC is equal to again B1 plus, sorry, what is the formula? Same formula is there, B1 plus 2N1 into TW into Fy divided by gamma m naught. So here N1 is equal to 2 into 2.5 into TF. So 2 into 2.5 into TF, the thickness of flange is 9.2 or 9.4. How much? 9.4. Okay. Sorry. 2 into 2.5 into 9.4. How much? 47. Okay. Now put these values. So FWC is equal to B1. B1 is 150, again 2 into 47 into TW is 6.7 into Fy is 250 divided by gamma m naught is 1.1. So tell me FCD value, FWC is in buckling, crippling strength in kilonewton. Three 371.55. 371.55. Okay. And last check for deflection. So check for deflection. It means we have to calculate delta actual. So if this is the UDL is given, then we have to calculate delta actual here. This is the delta actual. So before that we have to calculate the load given in the problem statement, that is the service load 40 kilonewton per meter. This is the service load. So here for delta actual for UDL, how much? WL raised to how much? किती है वो? What is formula? 5WL raised to 4 divided by 384 EI. So 5W is 40 into L. L is again 4000 raised to 4 divided by 384 into EI 2 into 10 raised to 5 into I, moment of inertia 7339.2 into 10 raised to 4. So tell me actual deflection in mm. Do the calculation and tell me. How much answer? I is 7332.9. Okay, 7332. Okay, okay, correct, and tell me answer. So actual deflection is in mm. How much? 9.09. 9.09 is the actual deflection. Is this correct? Anyone? Okay. So now calculate delta allowable, or we can say permissible. So how much? What is the formula for delta allowable? L divided by 300. So L is the 4000 mm divided by 300. So how much allowable deflection is in mm? 13.33. 13.33. So the check for deflection is here. Check for deflection is what? Delta actual is less than delta allowable. So delta actual is 9.09 mm is less than delta allowable is 13.33 mm. So here hence safe. So okay, so in this way we have to design the beam for the laterally supported. So next problem we will see on the laterally unsupported beam in the next lecture. uh, so here today we will stop because only 5 minutes are remaining, so we cannot start the next problem. So I have taken attendance also. So uh, you can, if your writing is over, you can left. I have taken attendance. Okay. Shall I close? Everyone's, yes, okay.